Good morning, everyone. Today, I am going to give my online lecture on Introduction to Digital Communication System. Myself, Dr. Tasleema Ahmed, Associate Professor in Department of Electronics and Communication Engineering at IIMT College of Engineering, Greater Noida. The topic to be discussed here that contents are first one is syllabus, then second one is course outcome, third one is CO and PO mapping, after that introduction, then block diagram of digital communication system, and after that types of digital communication techniques. First one, the syllabus that is prescribed by AKTU, the subject code is KEC 601, Digital Communication. And here the first unit covered mainly the concept of probability, random variable, then random process, after that power spectral density, and autocorrelation, function of random process, then Gaussian random process. Second unit in the syllabus is digital communication basics. And in this part, here discussing introduction to digital communication system, power spectral density of line coding schemes, then pulse tapping, after that scambling, then eye diagram, and last one is ground schematic orthogonalization scheme. In third unit, here mainly describe about digital modulation. What is modulation and demodulation of digital modulation? Different techniques that are amplitude shift key, frequency shift key, phase shift key, then differential phase shift key, quadrature shift key, then constellation diagram, and introduction to M-array communication. In fourth unit, here describe mainly about the digital receiver, optimum threshold detection, concept of max filter, then bit error analysis of different techniques that are already studied about binary ASK, binary FSK, then binary PSK. After that, introduction to spread spectra communication that are of two types, direct spread spectrum and frequency hopping. In our last unit, unit 5th, they are describing mainly the information theory. And here the topics to be covered are measure of information to information, entropy, mutual information, then mutual entropy, source encoding, and there are different techniques, Huffman coding, Shannon coding. After that, introduction to error analysis and detection. Then linear block codes, then cyclic codes. And after that, convolution code and decoding. The textbook that prescribe are BP Lathi, Modern Digital Analog Communication System. And another second one is we can also consider as Singh book, that is Communication System. The course outcome of this subject is very important, and here describing the main four outcomes that is obtained from the four different units. And also we can consider this for whole syllabus, what are the different outcomes. The first outcome is that is CO1, to formulate basic statistics involving communication theory. Second course outcome is to demonstrate the concept involved in digital communication. Then third outcome is to explain the concept of digital modulation scheme. Then fourth outcome is to analyze the performance of digital communication system. Then fifth outcome is to apply the concept of information theory in digital system. Then the gap identified across the syllabus, that is inter-symbol interference. Actually, that topic is very important and it should be included in digital communication syllabus. It is a phenomenon in which the energy of a symbol splits over into succeeding symbols, causing interference. Type filtering at the transmitter and receiver and or channel distortion can cause the waveform that represent a symbol is spread out into succeeding symbol periods. As from this waveform, we can see here, we are considering the binary bits 1 and 0, and for that the distortion and the signals are overlapping, and that is the transmitted waveform with a time interval of TB, and here the pulse dispersion is shown in the diagram. After that, introduction. What is digital and analog source and systems? The basic definition: analog information source. An analog information source produces messages that are defined on a continuum. That is the example of microphone. Then digital information source. A digital information source produces a finite set of possible messages, as for example typewriter. And both representation of signals are shown here, analog and digital. And here we can see that the analog signal is in continuous form and digital signal is representing in the terms of 0 and 1 different binary values. Here, why digital? Why we are required the digital signal and why this subject is very important? As we know that digital techniques need to distinguish between discrete symbols, allowing regeneration versus amplification. Good processing techniques are available for digital signal, as for examples, data compression, that is for source coding, error detection for channel coding or analog to digital conversion, then equalization and security purpose. The block diagram of the digital communication system is shown here, and here we can see the first block, that is our source, and the second block is our message encoder, and the third block, that is our channel encoder, and after that modulator, and then analog channels, then demodulator, and then channel encoder, after that message decoder, then our signal. One by one I am discussing here every blocks. The first one is source. As we know that sensor or transducer giving us electrical signals, and that electrical signals may be in analog form or digital. But first representation of the signal is physical. As we know that the physical quantities, as for example, temperature, pressure, level, weight, any type of signal. There may be vibration signal, there may be any type of fluid mechanics part, there may be any type of output from integrated circuit, and that should be converted to a particular level by using amplification technique so that we can represent our signal into a readable form. And the main function of the source part is conversion of physical signal into electrical signal. And after that, the message encoder will read the signal and we have to convert it into 0 or 1. As we know that our binary signal is in 0 and 1. And that means 0 means the signal that having level below the threshold value, and 1 that means the level that is greater than our threshold value. And for that, we have to convert the analog signal into a form that is in digital. And after that, we have to send it into channel encoder. And the function of channel encoder to encode the signals as per requirement. And after that, the modulation part. And that is very important part, as we know that in modulator part, the carrier signal and the information signal are to be added. As we know that our information signal has very low level of amplitude, low level of its strength. So we cannot transmit that particular signal. We have to add it to the carrier signal so that we are gain our particular signal to a particular level. That's why the carrier signal and the information signal is added in the modulator part, and that signal becomes now an in the form of analog. As we know that our transmission channels are wired or wireless. And for that, the here we shown the transmission line is analog. After the transmission of signal, we have to demodulate. As we know that demodulator part, that is the part of our receiver. And as we know that the source, from the source we send our information. That's why across the receiver, we have to again decode our signals, and that's why we have to separate both the information signal and the carrier signal. And after separation, again we have to decode the signal as per our application. And after decoding, we have again our decode our message signal. And after that, the sync part, that is our display part. Display part may be your personal computer, that is LED or LCD part. That is the whole block diagram of digital communication system and describing mainly the transmitter, receiver, and the connecting wire. Then the channel. That is very important part in communication system. The communication channel is a physical medium that is used for transmitting signals from transmitter to receiver. And that is maybe wired and that is maybe wireless. For wireless channel, that are system or wireless system. Wired channel, that is telephony. Then channel discrimination on the basis of their properties and characteristics like our additive white Gaussian noise. And the first part that we seen here across the block diagram, that is our source encoder and decoder. What is the function of that? Source encoder. In digital communication, we convert the signal from source to digital signal. And in source decoder, at the end, if the analog signal is desired, then source decoder tries to decode the sequence from the knowledge of encoding algorithm. Then channel encoder and decoder. The channel encoder, the main function, the information sequence is passed through the channel encoder. The purpose of channel encoder is to introduce in control manner some redundancy in the binary information sequence that can be used at the receiver to overcome the effect of noise and interference encountered in the transmission on the signal through the channel. Then channel decoder attempts to reconstruct the original information sequence from the knowledge of the code used by the channel encoder and the redundancy contained in the received data. Then digital modulator and demodulator. Digital modulator, the binary sequence is passed to digital modulator, which in turn convert the sequence into electric signal so that we can transmit them on channel. The digital modulator maps the binary sequence into digital. Digital decoder, the digital demodulator processes the channel corrupted transmitted waveform and reduces the waveform to the sequence of numbers that represents estimates of the transmitted data signal. Then digital communication system advantage and disadvantages. The main advantages here we can easily see. The first one is relatively inexpensive digital circuits may be used. Privacy is preserved by using data encryption. Data from voice, video, and data source may be merged and transmitted over a common digital system. In long distance system, noise does not accumulate from repeater to repeater. data regeneration is possible. Error in detected data may be small even when there is a large number of noise on the received signal. Error may often be corrected by the use of coding. Disadvantage: generally, more bandwidth is required than for analog system. Synchronization is also required in digital communication system. Then digital to digital conversion. As we know that the topic of discussion is digital communication. That's why we have to convert our analog signal into digital form, and digital signal that is obtained from digital data. That's why that is the very important part of studying this part. And here we see the representation of digital data by using digital signal. The conversion involves three techniques: line coding, block coding, and scattering. The line coding is always needed. Block coding and scrambling may or may not be needed. Topics discussion for this section is line coding scheme, then scattering. Line coding. As we know that we have to convert our digital data into digital signal, and that means we are coding our data in the form of signal. That's why that is named as line coding. Converting a string of ones or zeros that is in digital data into a sequence of signals that denote ones or zeros. For example, high voltage level signal that is in positive voltage level could represent it as 1, and a low level signal that is 0 or minus volt that could be represented as 0. That means we can set a threshold value, and above the threshold value that is considered as 1, and below the threshold value that is considered as 0. And here we saw the line coding and decoding techniques. As we know that our digital communication system has different parts: transmitter, receiver, then our line coding techniques, and the transmission part. That's why encode the signal across the sender and across the receiver, we have to again decode the signal. That's why the line coding part is very important, and digital data here soon that is converted into signal, and in the form of signal it is transmitted, and at the receiver we are getting the signal and we have to decode our original signal. Mapping data symbols and signaling level. A data symbol or element can consist of a number of data bits, that is 1 or 0 or 1 1 or 1 0 or 0. A data symbol can be coded into a single signal element or multiple signal element by considering its level. As it is greater than the threshold value, that is positively, we are considered as 1, and below this value, we considered as 0. Like that, we can also set the value for minus V or plus V. The ratio R, that is the number of data elements carried by a signal element. After that, different line coding techniques, and that is important part of study in this subject. There are different types of line coding. First one is unipolar, then polar, then bipolar, after that multi-level, then multi-transition. Unipolar technique, again, it can be divided into different types. As we see here, non-return to zero or return to zero, biphase, that is described in Manchester, and differential Manchester. Unipolar technique. All signal levels are one side of the time axis, either above or below. Non-return to zero. Non-return to zero scheme is an example of this. The signal level does not return to zero during a symbol transmission. This scheme is used for baseline rendering and DC components. It has no synchronization or any error detection. It is very simple but costly in power consumption. Then the unipolar representation of the signal, here we see that unipole. That means it has only one pole, either positive, either negative. That's why here considering the positive pole, in case of 1, it becomes high, represent the maximum voltage level, that is V. In case of 0, it is in lower level, that is in 0 level. And like that, 1 representation and 0 representation is shown in the diagram, and it is clearly described by this diagram that is unipolar. After that, polar non-return to 0. The voltages are on both sides of time axis. Polar non-return to 0 scheme can be implemented with two voltage levels. For positive V, it is 1. For negative V, it is 0. There are two different versions, non-return to 0 and return to 0. And we already see the levels for 1 or 0. Then polar return to 0 level, that is shown in the diagram easily. Here we know that polar. That means it has two poles. For 0 case, it is simply considered as our positive voltage, and for 1, it is considered as minus voltage level. And in inversion techniques, in the second wave, we see the inversion of the first wave. And that's why that signal becomes polar, because it has two levels of representation of both data 0 and 1. Then polar return to 0. The return to 0 scheme uses three levels: positive voltage, then 0, then negative voltage. Each symbol has a transition in the middle part, either from higher to 0 or from low to 0. This scheme has more signal transitions, two-part symbol, and therefore require a wider bandwidth. No DC components or baseline rendering in this technique. Then self-synchronization transition indicates symbol value. More complex as it uses three voltage level, it has no error detection capability. And here representation of simple polar return to 0 scheme. As we know that in case of return to 0, the positive half of any data symbol becomes in 0 level, and for negative half, it again becomes in same level, and for 1, here we see that the first half of signal is in positive level, and after second half, it becomes 0 level. That means is defining, and there are different transitions in the signals. And we can easily detect our noise here from this signal. Then polar biphase, that is Manchester and differential Manchester. Manchester coding consists of combining the both return to 0 and non-return to 0. Every symbol has a level transition in the middle from high to low or low to high. Uses only two voltage level. Then differential Manchester coding consists of combining both techniques, non-return to 0 and return to 0. Every symbol has a level transition in the middle. But the level at the beginning of the signal is determined by the symbol value. One symbol causes a level change, the other does not. And from the waveform, we can clear it as here we see that for 0 level, it becomes high for the first half cycle, and it becomes in negative level for the second half cycle. And in opposite case is going on for 1. For one, the first half cycle is in negative level and the second half cycle is in positive level. And like that, we are obtaining different levels in across the Manchester coding. And the width shown here. Then scambling. Actually, scambling is the technique for removing the noise and to removing the DC component in digital communication system. The base code is one that does not increase the band for synchronization and has no DC components. Scambling is a technique used to create a sequence of bits that has the required zeros for transmission, self-clocking, no low frequency value, no white pattern. It is implemented at the same time as encoding. The bit stream is created on the flip. It replaces unfriendly runs of data with a violation code that is easy to recognize and remove the unwanted zeros. And how this is possible? We can see here there are two types: bipolar 8-0 substitution and scambling. And here we can see that if there are continuous zero in our data and it becomes providing the low frequency and create problem during transmission. That's why the continuous zero can be represented as by this techniques. For the first one, we are considering the high value. For the next three zeros, that signal is in zero level, and the fourth zero, it becomes again high, and then fifth zero, it becomes again bipolar condition, and like that, the representation of signals and its negative level is also shown in this diagram. Then the another technique of scambling, that is high density bipolar tree method. And in this method, we can substitute the four consecutive zeros with 00V. V means violation, or B00V. That means bipolar 00 violation. And for that, we are seeing here, if number of non-zero pulses is even, then the substitution will be B00V. If number of non-zero pulses is odd, then substitution will be 00V. From this waveform, we can clearly visible here even number and odd number. As the first two data are 1, that means continuously two datas are in even number, and that's why we are using here the simple scheme bipolar 00 violation. After that, the data is 1, and that is one single data, that is odd number. That's why we are using here simple, the technique is 00 violation. After that, again the data are in even number. That's why we are considering the level is bipolar 00 violation. And that is the main scambling technique. Thank you.